Hello again. In this video, I'm finally going to finish the shepherd's hut roof. But first, allow me to remind you of the build so far. First up had been to make the curved oak beams, the bones of the roof structure, made entirely from reclaimed oak timbers from a house demolition. After flattening the best face by hand, I sent them over the surfacer and through the thicknesser, taking them down to 80mm. Then I used a circular saw to rip them into 10mm strips, which felt like it retained just the right amount of springiness. The plan was to bend 7 strips together with glue in between to create curved laminations, but because I needed 9 of these curved beams, I had to make up more than 63 strips in total. I also needed a very strong jig that would resist the immense power of the oak bending, which I made from a sheet of plywood screwed down onto a frame and with blocks of timber fixed on top in a slightly tighter radius than I wanted to allow for the inevitable spring back of the laminations once I removed the clamps. Next, I carefully selected bunches of 7, making sure to sandwich any strips with imperfections in the middle, with the best ones on the outside. The glue of choice was Titebond 3, which gave me about 30 minutes to get the job done. That sounds like a long time, but there were many steps. First, I put glue on the top face of each strip using a roller. Then I began stacking them, making sure to also put glue on the remaining face to ensure maximum coverage. Then I mounted them onto the plywood jig and began the race to bend them into a curve before the glue set up. Each one proved different with various issues, and so the first few times were a little stressful, especially as I was filming it too. But thankfully there were no issues I couldn't resolve, not least because I had plenty of pivot handle Bessie clamps. You really can't have enough clamps. Once the glue was dry, I removed it from the jig, and here you can see that spring back I was talking about. The equation I used to estimate this was spot on. Then I had to repeat the process again and again for about 2 weeks until I had 9 curved oak roof beams. But the job was far from over. So I loaded them onto the truck and took them around to the workshop to begin the precision engineering. First, they needed cutting down to a reasonable length, and as you can see by the end grain, the glue laminations were nice and tight. Then I sent them through the thicknesser a couple of times to level out any high spots. This was a bit tricky due to the curve, but it now revealed the beautiful layers of the seasoned oak, which will be visible from inside the shepherd's hut, and I couldn't be happier how they turned out. Unfortunately, the big issue was that most of them had a twist, owing to the jig deflecting during clamping. Turns out it wasn't strong enough, and so the plywood had actually flexed at the ends. The consequence of this was that nothing on these beams was 90 degrees, which was problematic as I needed to mark and cut the bird's mouths on the ends to sit on top of the wall plates. By using a shim, I created 3 points of contact to the workbench, which meant I could slide the beam around, locked on the horizontal plane. And then with the portable bandsaw mounted perfectly perpendicular to the workbench, I could make the first seat cut of the bird's mouth, spin it around and do the same on the other end, knowing the cuts would be on the same vertical plane. Then I made the plumb cut by hand. It's a little hard to fully appreciate, but this method ensured the seat cuts were in line with each other, and the best ways to check this was with a couple of sticks. As you can see, they were parallel with each other, which confirmed the seat cuts were accurate, which was crucial for them to sit evenly onto the wall plates. With the difficult bit done, the oak needed some protection from dirty fingerprints. So first I used this cabinet scraper, a magical little tool, to create lovely smooth faces which are then coated with some varnish. These beams are really the most valuable component of this roof. I dread to think how much a business would charge to make them. Next, I set up the 2 wall plates on the chassis exactly 2 meters apart and mounted the curved beams on top. All the bird's mouths were sitting beautifully flat even before fixings. Now, because I'm going to need to take everything apart in the future, multiple times, I needed to use bolts, the king of fixings, to connect the beams to the wall plates. Man, do I love bolts. They guaranteed the joints were rock solid, and I had no concerns walking on top of the beams, which are themselves one of the strongest timber roof structures it's possible to build. You could drive a tractor over these. So then it was onto the ceiling boards. Now, I would have loved to make these from more oak, but it wasn't feasible. Instead, I'd bought some 9mm moisture-resistant bead and butt MDF sheets for the wall coverings, so I decided to experiment with them instead. The big issue was that they weren't flexible enough to match the curve of the roof, so I made a load of 6mm relief cuts in the back face to intentionally weaken them, which allowed me to clamp them down to the form of the curved beams. This alone would not be sufficient, so then I mixed up a batch of filler and began the tedious process of filling all the cuts back in to re-strengthen the MDF and lock that curve in. As MDF is somewhat vulnerable to moisture, I then put a few coats of a solvent-based primer on to help seal it up, then repeated the process a number of times until I had enough curved sheets to fill out the entire 6 meter long roof. So it was on to the final layer of carpentry. A carcass frame the MDF would be fixed up into, and which would create cavities into which I can put insulation. So first I marked another radius on a sheet of 18mm plywood, cut it out with a jigsaw, and then doubled it up to 36mm for strength, because these will overhang the walls, creating the eaves. Then I used a flush router bit to ensure all the curves were identical to each other, which was far less effort than trying to cut them identical with the jigsaw. As I said, these are designed to extend beyond the walls, keeping rain off. Basically rafters with tails. And rafters need to sit on purlins, which is essentially what these 6-meter long stud timbers are. To merge them into one layer, I cut pockets in both, which would slot into each other. Everything was glued and screwed together, and because all the joints were pre-cut, it went very smoothly. Basically just a big jigsaw puzzle. Solid. Once it was assembled, it was over 2 meters wide, 6 meters long, and weighed 105 kilograms, and required some improvisation to lift it up out of the way. Then I snapped some chalk lines to mark where the stud timbers had been, and began pre-drilling a couple of hundred holes through which I'd screw the MDF up into the carcass frame. These holes were countersunk so that I could eventually fill them in and paint over. Then it was time for the final glue up, so we laid down a few tubes of construction adhesive, and then lowered the carcass frame onto the MDF, and another race was on to get all the screws in before the glue set up. And that is where we got to in the last video, a complete roof structure. But there were a couple of issues that needed addressing. The first problem had occurred during the glue up. I'd sunk some long screws down through the carcass timbers into the curved oak beams without pre-drilling. And when I tried to remove the screws, 3 of them snapped, leaving the 5cm long threaded part of the screws deeply embedded into the oak, with no way to rotate them. If you've ever tried removing a snap screw, you will understand that it's possible, but it gets very ugly very quickly. Typically you drill a bunch of holes around it, removing all the material around the threads until there is nothing holding it into the beam, and you can pull it out. But it's messy. Instead, I came across a diamond-tipped, hollow drill bit made by JCB, not designed for wood, but masonry and metal, which had the potential to remove the screw in one nice clean hole. Unlike a normal drill bit that cuts, this one abrades like sandpaper, so generates a lot of heat. But it was successfully breaking the holes of the threads into the oak, and meant I could try some vice grips to rotate the screw out. Nope. Pretty much the entire oh yeah. That's how you do it. To fill the hole back in, first I used a larger drill bit to remove the charred oak, which doesn't absorb glue very well, and then knocked in some dowels to fill in the empty space. Clearly using screws to fix the roof down to the oak beams wasn't my best idea, so instead I planned to use coach bolts going up through the beam, meaning I needed to drill some bolt holes through everything, almost exactly where the dowels are now glued, but I'll do that at a later stage with everything back together and aligned again. When I first cut the bird's mouth on the curved beams, I thought I'd be using this stud timber for all the walls, but it's a pain to work with because it's never the same dimension, is often bowed, and I don't want to spend hours sorting through to find the good bits at the builder's merchant. So I found a better, more accurate stud timber to build the walls with. The only problem is that it's 5mm wider. So I needed to redo the plumb cut of the bird's mouth, and the easiest way to do that was fixing a thin piece of board and making a flush cut. Once I'd enlarged all the bird's mouths on all 6 beams, I could mount them to the new wall plate on the left. As you can see, it's wider, but not as thick, at 80 by 60 millimeters compared to 75 by 75 of the original. I'll talk more about this stud timber when I build the walls. So then I cut off the tails of the bird's mouths, which I'd left long, and moved on to the challenging task of drilling the new holes for the coach bolts up through the centre of the roof. The bolts will replace the old system of screwing the roof to the curved beams, ensuring no more issues with snap screws. But the holes have to go through 70mm of curved beam, 9mm of MDF, and another 80mm of roof carcass timber. So it's a long bloody hole and has to hit the centre of everything, and there weren't any 90-degree reference points to help me, so quite an ask. Basically, I lined everything up as well as I could with some lasers, set the drill speed to low, and crossed my fingers the hole would still be in the centre when it came out of the top timber. Ooh. Then I climbed onto the roof and routed out a section where I could eventually fit a washer and nut. This is the new system for attaching the roof down onto the curved beams, and it will be a lot stronger than the screws because of the superior clamping power of bolts. They'll also help align the components of the roof during assembly, so definitely a much improved system. With that done, now it was onto the eaves. I'd left the MDF proud of the roof carcass, so the first job was to cut that back flush. Quite an unpleasant job, to say the least.
That was awful.
I got a lot of stick for using MDF in the last video, and of course I'd much rather have used oak for the ceiling boards, but I didn't have the time, funds or machinery to make up a load of narrow oak planks myself, and it's not the sort of thing you can buy easily. So this was the best option. Maybe in a few years I'll remake the roof, but for now the MDF will have to do. And I think it will do fine. Anyway, I next had to fill in all the screw holes I'd made when fixing it to the roof carcass. To make the job a bit faster, I used this 2-part wood filler, which hardens in 30 minutes and doesn't shrink as much as the powdered stuff. Getting the timing right was the main challenge, to make sure it was hard enough so it wouldn't rip out, but soft enough to sand back without digging into the MDF too much with the sander. You may have realised this is painting and decorating now, and took a lot more work than I would have liked, especially as I was working overhead. If I'd used oak planks, I would have avoided almost all of this, but that was the price to pay. With the holes filled, it was on to painting. I used the same solvent-based primer as on the top, Zinsabin, and this should add a strong layer of moisture protection to the moisture-resistant MDF. And then where the roof extends beyond the wall plate, i.e. the part of the ceiling boards that you'll see from outside the shepherd's hut, I painted the MDF with anthracite grey exterior paint, which will match the colour of the corrugated roof sheets. So the corrugated roof sheets should prevent any water getting into the roof carcass, but on the eaves, where the rain runs off, the timber and MDF are more vulnerable. Especially if there's a bit of wind, the drips will get blown back and over time may cause issues. I actually cut the plywood curves back to that black line, so there is a wider overhang than you can see here that should prevent most of the rain coming back. But what I really needed was to physically protect the full 6 meter long eaves with a fascia board. The options were cheap plastic PVC or more expensive aluminium. So of course, I went with the aluminium. But first I adapted a sample of the fascia board to get my dimensions correct. So any rain that does get onto the eaves will just drip off from this bottom edge of the aluminium, making it very unlikely any water will reach the timber or MDF of the eaves. So then I placed the order for the full 3 meter long, 1.5mm thick U-profile fascia boards. These were a little pricey at €60 a pop, plus shipping, but they're pre-coated in anthracite grey, the same colour as the corrugated roof sheets, and will add a decent amount of weather protection to the eaves and will be reusable, so definitely a worthwhile investment. The maximum length I could order was 3 meters, which left me with a small gap in the middle of the roof, which is just over 6 meters long. So then I cut a small cover strip from a slightly wider U-profile piece of aluminium, which I could then fit over the top of the gap. To protect the curved plywood ends at the front and back of the roof, it required a more custom approach, so I'd also ordered a full sheet of the aluminium to cut down and shape for myself. First I mounted it to the roof so I could accurately mark the radius of the curve. I'm going to cut it about 10mm lower than the MDF to form a drip edge, so water won't get pulled back up. Okay. plan here was basically to create a piece that matched the curved plywood ends with an extended drip edge on the bottom and a 90-degree return bend on the top to give me some material through which I could screw it to the plywood. But because it wasn't a straight bend, if I'd tried to hammer the aluminium without first cutting these reliefs, it would have just crumpled into a mess, preventing the roof sheets from sitting nicely onto the plywood. As you can see, it went pretty well. The only difficulty was to keep it tight against the plywood, as each blow wanted to push the aluminium away from the end face, so I used a block of wood to clamp it flat. My arm's about to fall off. A few thousand blows later, and I had perfectly shaped end pieces that gave the end plywood complete protection from the elements, with plenty of points to screw it down. And that was all the eaves, now weatherproofed. So it was on to the major issue with the roof. Have a think what that was. Of course, the size of it. As you know, I'd built the roof as one full 6-meter long structure. This had made it much easier to fabricate because I was on an uneven dirt floor in an old barn. But the consequence was that it was much harder to handle. The only way to move it around would be on top of the rolling chassis, and the only way to lift it up would be with a chain hoist mounted to something much higher than the height of the shepherd's hut. So two rather inconvenient restrictions. Basically, the only option was to cut it up. And luckily, there were 2 points where the MDF sheets meet, and which are also hidden from below by the curved oak beams. So this is where I could split the roof into 3. In hindsight, I could have set out the plywood curves to make this easier, and if I ever do remake the roof, I have some ideas on how to incorporate that. But I still like the option of being able to lift the roof as one whole structure. So I devised a system that would allow me to reattach the 3 individual sections of the roof back together. First, I fabricated a load of these steel bars, each with 3 holes for bolts to go through. No easy feat on a hobby drill press, let me tell you. When building with bolts, but making it up as you go along, like this, I've realized it's much more affordable to have a few lengths of M10 or M12 threaded rod you can just cut to size as a temporary placeholder, and then once you know the exact lengths you need, to order them online in bulk. Buying correct bolts as you need them from the local builder's merchant really starts to add up in cost. And if you want to use stainless steel, which I prefer for a roof application, you have to go online anyway. So by using one of the bars as a guide, I drilled holes through the long purlin timbers of the roof. Accuracy was key, as I needed to make sure the exit holes would align with the steel bar on both sides of the timber. The maths were quite substantial. 60 holes to drill through the thick steel bar, 30 holes to drill through the timber, and 30 pieces of threaded rod. So you can imagine how long all that took. And I did all of this before cutting the roof, as once it's split, I'll struggle to get all 3 sections perfectly aligned and level again. With the system to reconnect the roof back together finished, it was time to make the 14 cuts that would divide the roof into 3 parts. No going back now. It definitely felt a bit odd to be cutting something this size into sections, so once it was done, I was eager to put the bar and bolts through to see if the system actually worked and whether I'd still be able to lift it again as one whole roof. But before that, let me introduce the newest piece of workwear I've been developing. It's a lamb's wool sweater made in Britain using British wool, and quite simply the best all-round jumper I've ever owned. Maybe even too nice to use in a workshop. Yeah, it's good. That's it. Thank you. So of course the roof all went back together fine, and the steel bars were more than capable of holding the 3 parts together to lift it as one entire roof. The only potential issue may be aligning the holes I drilled for the coach bolts, but we'll see. But we'll probably have to come out this way so I can get out, because I can't walk across there. Right. Hold on.
be easier to move those bits of wood. Go towards you. We can go across like that now.
Yeah.
Until it takes the weight. Yeah? Are you twisted? Hold it there, that'll put it down.
Yeah, but I'm on the beam.
Yeah, I know, that's what you want.
No, I don't.
Alright. Is my weight first?
Alright, I'll just go towards you. Because the beam's in the way of me. So what did all of this achieve? Well, it meant I could do 3 very important things. The first was to actually move the roof around with the help of any unfortunate person nearby. Thanks, Dad. The 2 larger sections of the roof weigh around 75 kilograms each, so just within reason for 2 people, whilst the smaller middle section is about 40 kilograms. The second point was that I can now transport the roof on a normal size trailer if I need to. And last, but certainly not least, as you'll see shortly, this made it possible to lift the roof in sections onto the top of the shepherd's hut walls. To lift the roof as one would have required either a crane or a couple of high scaffolding towers with a hoist at 5 meters, basically something with a lifting point higher than the shepherd's hut itself. So that is the roof complete and ready to go up on the walls, which you'll see me build very shortly. I'm sorry to have kept you waiting so long for this new video. This year did not go to plan and life got very complicated. Thank you to everyone who reached out, and apologies if I didn't get back to you. I hope you can understand that I can't go into all the details, but I have reached a milestone with this shepherd's hut build, which will be shown in the 3 upcoming videos. And on another positive note, it has given me time to develop this next piece of workwear. Although, as I said, this is arguably a little too nice to be used for working in, unless it's under a jacket, of course. It's a lamb's wool sweater made in Britain using British wool, a remarkably resilient material. This one I've worn literally hundreds of times over 3 years, believe it or not, and it still looks the best of all my sweaters, even the new ones which are made in China. So expect to hear more about the sweater in the upcoming videos. A limited number are now available for pre-order over at cotaworks.com. Just make sure you measure your full chest first before ordering. There's also a beanie made from super soft Irish merino wool available. Both are shipping in 4 weeks, just in time for the winter. As always, thanks for watching. Thank you for waiting. Thanks for supporting. Next video coming in a week.